Now this module is all about PyTorch. What is PyTorch? It's an open source machine learning library developed by Facebook, or I guess now that's called Meta. It offers a flexible and dynamic framework for building and training neural networks. In practical terms, it provides software tools, so class objects like torch.nn.linear, we will discuss that in detail later on, so tools that automate many aspects of machine learning algorithm development, training, and testing. As a result, PyTorch is widely adopted by engineers and computer scientists for both machine learning research and production. Now, we're only going to be using PyTorch for the Python programming language, and that's the most popular way, the predominant way in which it's used, but I thought I should provide the caveat that there is some version of PyTorch available for C++, although I've personally never used that. The most popular alternative to PyTorch is TensorFlow, which we're not going to discuss here. They're both great options. Generally, PyTorch is considered to be better for research. It provides a little bit more flexibility, but it's not as efficient as TensorFlow. So TensorFlow may be preferred by industry for production level designs, but both share many capabilities and features. So learning about PyTorch will definitely give you a leg up on learning more about TensorFlow and using that later on. Now, PyTorch represents data as tensors, rather than arrays or matrices, but for the purposes of this module, these can largely be considered equivalent. We will talk more about tensors later on in this module, but it's not a focus here, and I don't want to get too lost in the weeds. One key advantage of using PyTorch over base Python along with NumPy, a numerical calculation library, is its automatic differentiation or auto-gradient capability. Each time PyTorch performs an arithmetic operation on or applies a function to a tensor, to some data, it also computes the derivative of the result, or the output, with respect to the input or certain designated parameters, both automatically and in parallel, hence the name automatic differentiation. Now, one note, you do have to turn on this auto gradient capability, so it's not always active. This gradient information is critical for machine learning techniques such as backpropagation and gradient descent, and they play a really important role in training. I know we haven't discussed these topics yet, but we will address them in future modules. Now, this module specifically focuses on translating the MATLAB Perceptron machine learning code, the one we developed as part of the last module. We want to take that from MATLAB and translate it to Python using the PyTorch library. And we're going to do this in two steps. So first, we translate the commands one for one, or as close as possible, and then we test this approach. Then, we reformulate and completely rewrite the script to take full advantage of important PyTorch features and capabilities. And before we perform this translation, we'll highlight what those